And what it was found is that people with a higher omega-3 intake slowed their age acceleration. So, you're accelerating, your aging is happening at a certain rate. If you're smoking, it's happening at an accelerated rate. If you're taking omega-3, it's slowing that rate of acceleration. But what was really fascinating is that there was synergy. So when you looked at omega-3 plus vitamin D, it slowed epigenetic aging even further than just omega-3 alone. It slowed it by about 3.3 months. When you looked at all three combined, resistance training, omega-3 and vitamin D, it slowed it by about 3.8 months. So really it was like these healthy lifestyle factors converging, with omega-3 being the thing that's really moving the lever. So excited to be here, Expo West. I had no idea how big of an event this was until I was driving here in traffic, and I thought everyone was walking to Disneyland, and I'm like, this is not the Disneyland crew. So as Harmony mentioned, I am a huge advocate of omega-3. I mean, this started from, when I was a graduate student. I started, supplementing with omega-3 back in 2007, just reading the scientific literature and realizing how important it was. And then when I went on to do my postdoc with Dr. Bruce Ames, the late Dr. Bruce Ames, he's a UC Berkeley professor, but I was at Children's Hospital Oakland Research Institute, and I was researching omega-3 in his lab as well. So it's been not only a passion of mine at the personal level, but also something that I research and I continue to research as an associate scientist at the Omega-3 Fatty Acid Institute that was founded by Dr. Bill Harris. So today I'm going to be talking about how we can all optimize our longevity with the power of omega-3 through the delay of age-related disease and through the delay of the molecular events that lead to age-related disease. And we're talking about cardiovascular disease being a big one, cancer, Alzheimer's disease, these diseases that not only shorten our life expectancy, but also decrease the quality of our life, right? We don't want to live the rest of our life with Alzheimer's disease, the last 10 years with Alzheimer's disease or with cancer. This is a standard disclaimer here. I am a scientific researcher, and so what I'm presenting here today is not medical advice. It doesn't represent any omega-3 supplement company's views. It is my views. These are my slides. This is what I present when I go around and do presentations. So just keep that in mind as for informational purposes only. It's not meant to be prescriptive. Okay, so just to give you an overview of what we're going to talk about today, first we're going to talk about the role of omega-3 in cardiovascular health. We're going to talk about cardiovascular events. We're going to talk about all-cause mortality, and then we're going to talk about some of the mechanisms like inflammation and changing what's called cell fluidity, and we'll talk about what that means. We're going to talk about how omega-3 slows the aging process. It slows biological aging. We're going to talk about how it synergizes with other micronutrients and lifestyle factors like vitamin D and exercise. We're going to talk about the role of omega-3 in delaying age-related neurodegenerative disease like Alzheimer's disease. We're going to talk about how it plays a role in preventing brain atrophy as we age and also improving cognitive function. And then we're going to get into the muscle and talk about disuse atrophy when we're not using our muscles and how omega-3 plays a very unique role in helping prevent some of that disuse atrophy and why that's so relevant. And then we're going to talk about the gut. We're going to finish on the gut, which is actually a major source of inflammation. And so we're going to talk about a unique way that omega-3 is actually playing a role in inhibiting leaky gut. So I want to just get started with the first slide here, which really highlights the prevalence of omega-3 insufficiency and deficiency. People are not getting omega-3 fatty acids from their foods. So about 90% of the US population does not eat enough seafood, and about 80% globally of the population is not getting enough omega-3 from their diet. Which leads me to this really important study that was published out of Harvard several years ago that identified low omega-3 intake as one of the top 6 preventable causes of death. So there are 3 types of omega-3 fatty acids. There's alpha-linoleic acid, ALA, that is found in plant foods like walnuts, like flax seeds, chia seeds. And then there's the marine type of omega-3 fatty acids, eicosapentaenoic acid, EPA, and docosahexaenoic acid, DHA. And those are found primarily in seafood. And so what this Harvard study identified was that people weren't eating enough of the EPA and DHA from seafood. And why is that important? What do I mean by top 6 preventable causes of death? Well, what these researchers did was they looked at all the different things that people have control of, in their life and diseases that increase early mortality. And top 6 of those were things like smoking. So if you avoided smoking, you would, live longer. If you didn't, you would shorten your life expectancy. Hypertension, type 2 diabetes, cardiovascular disease, and not getting enough omega-3 from your diet, right? Nobody is thinking about that. Everyone's thinking about all these other diseases. They're not thinking about what they're not getting from their food. It was actually found that 84,000 deaths a year were attributed to people not getting enough omega-3. And by people, I mean in the United States. We're not getting enough omega-3 from their diet. And compare this to people eating trans fats. So trans fats, everyone knows it's terrible for cardiovascular health. It leads to cardiovascular disease. And that was attributed to 82,000 deaths per year. And when anyone walks into a grocery store, you can pull into any aisle and pick up, food, and it'll say zero trans fat, zero trans fat. It's marketed everywhere. Everyone's thinking about not consuming trans fat because it leads to early mortality. But nobody's walking into a grocery store and thinking, am I getting enough omega-3? Am I getting my fatty salmon? Am I getting enough seafood? Nobody's thinking about that, but they should be. It's very important for our health. So let's talk about, how we can measure omega-3 and how we know it's important for our health. But there's large studies that have been done, longitudinal studies, Framingham cohort being a big one, where lots of different blood biomarkers have been measured in individuals, including the omega-3 index. So the omega-3 index is a marker of your omega-3 fatty acid levels in blood cells. So it's a long-term marker because your red blood cells take about 120 days to turn over. So it's nice to have more of a long-term marker of omega-3 versus just looking at omega-3 in plasma phospholipids, which to some degree could be reflective more of what your, recent diet was versus more of your long-term omega-3 status. So Dr. Bill Harris, and his colleague Clemens van Schacke had identified this omega-3 index back in, I think it was like 2002, 2004, something like that. And so, when they measured, thousands of people's omega-3 index, what they found was that those people with a high omega-3 index that's indicated as 8% or more, so 8% of the fatty acids in the red blood cell membranes were composed of these omega-3 fatty acids. They had a 90% lower risk of sudden cardiac death compared to people with a low omega-3 index, being 4% or below. 90% lower risk of sudden cardiac death. That means, if someone had a heart attack and they had a high omega-3 index, they were 90% less likely to die from that heart attack than someone who had a heart attack that had a low omega-3 index. That's a big difference. And if you think about heart attacks, every 30 seconds, someone in the United States is having a heart attack. So this is a really important finding. But it's not only important for reducing the risk of sudden cardiac death, it's also been linked to our life expectancy. So yet again, looking at the omega-3 index in people, I think this was maybe the Framingham, this was the Framingham cohort. Again, this is a very large population of people where a variety of different biomarkers have been measured. Those individuals with a high omega-3 index of 8% or higher had a 5-year increased life expectancy compared to people with a low omega-3 index of 4% or lower. 5 years is a big difference in life expectancy. And really all we're talking about here is the difference between having a high omega-3 index and a low omega-3 index. If you think about other countries that actually do eat a lot of seafood, like Japan, for example, in Japan, their average omega-3 index is 10%. So they're in that high omega-3 index range. In the United States, our omega-3 index on average is about 5%. So we're pretty close to that 4%, which is the low range. And if you look at the difference in life expectancy between people that are in the United States versus people that live in Japan, it's about 5-year difference. So people in Japan have a 5-year increased life expectancy compared to people in the United States. From that same Framingham cohort, and this is the data that I find so compelling, and you may have heard me speak about this before, and I really like to talk about it, and I like people to see the graph because visually it's just so clear. So what Bill and his colleagues did was they took this Framingham cohort and they took the people with the high omega-3 and the low omega-3 index, And they said, okay, I want to look at these individuals and I want to specifically look at smokers versus non-smokers with a high and low omega-3. Because we know that smoking, one of the worst things you can do for your cardiovascular health is smoke cigarettes. A lot of people associate cancer, lung cancer, with smoking, when in fact, lung cancer increases in a sort of dose-dependent manner. The more cigarettes that you smoke, the higher the risk of lung cancer, and that sort of compounds over time. When it comes to cardiovascular disease risk, that's an exponential increase. It doesn't take much. And that is because, the damage that the tobacco smoke is doing to the endothelial cells and the inflammation that's being generated, really, really bad for cardiovascular health. And so if you look at individuals that have the highest life expectancy, that would be in green. They were non-smokers with a high omega-3 index. They lived the longest. Big surprise. People that live the shortest life expectancy is what you would expect. Smokers with a low omega-3 index. That's red, so they're dying sooner. But what's so fascinating is that when you take the smokers that actually have a high omega-3 index, they have the exact same life expectancy as the non-smokers with a low omega-3 index. And really, you can look at this data and go, wow, I don't smoke, but it's like I smoke. Low omega-3 is like smoking when it comes to at least our overall life expectancy. Of course, all the smokers, when I present this data, think, oh, yes, I got to take omega-3. Of course, that's the wrong way to look at it, right? Because you want to be that green curve. You want to be the non-smoker with a high omega-3 index. But it really just highlights, we know, and we're going to talk a lot about this today, that omega-3 fatty acids play a very, very important role in cardiovascular health. And that is why, one, I think they're really similar. Not getting enough of that in your diet is very similar to consuming trans fats. We're always worried about the things that we're, the toxins that we're getting, when also we should be worrying about what we're not getting. Because what we're not getting, our body needs certain nutrients to function normally and optimally. And what we're not getting is also like a toxin. We are smoking when we're not getting enough omega-3. So let's talk about cardiovascular health and the gold standard for cardiovascular health, which would be randomized placebo-controlled trials, of which there have been quite a few omega-3 fatty acid trials that have looked at cardiovascular health. So the first one that I think has probably one of the most robust effects is the REDUCE-IT trial. This was about a 5-year randomized controlled trial where individuals were separated. These are individuals with high risk for cardiovascular disease. Many of them are already on some kind of first-line standard of care treatment, like statins, for example, and others. And they were given either 4 grams of Visipa. This is a pharmaceutical grade prescription form of purified EPA, or they were given a placebo control for 5 years. And after the 5 years, a variety of different outcomes were looked at, right? And what was found was that the people that were given this Visipa, this high dose EPA, and it was 4 grams, they actually had about a 25% lower risk of all sorts of cardiovascular events, death, ischemic events. So we're talking a pretty big effect here on lowering the risk of heart attacks and strokes and ischemic events. The next trial that had positive results was the VITAL study. And the VITAL study was a really big trial, and it's still ongoing, and people are still harvesting data from this trial. There's a lot of components to the trial, but I'm going to talk about the omega-3 component, where individuals were given a very low dose of omega-3 fatty acids, actually. They were given Loveza. This is another prescription form of omega-3. In this trial, they were only given 840 milligrams of Loveza, which is a combination of both EPA and DHA, or they were given a placebo control. And this was also a 5-year trial. After the 5 years, some of the secondary outcomes that were looked at were actually improved with respect to cardiovascular health. So individuals that were given the prescription in Loveza had a 28% lower heart attack risk, and they had a 17% lower coronary artery disease risk compared to those given a placebo. And that was at a pretty low dose. I mean, we're talking less than a gram a day. So pretty compelling data. There's also the strength trial. This was 4 grams of EPA and DHA. This was Epanova. Epanova was and is omega-3 fatty acids in free fatty acid form. So usually these fatty acids are esterified. Both of these that I'm talking about here prescription form, Vascepa and Luveza, are in a ethyl ester form, which is not quite as bioavailable as being in a triglyceride form, which is what you find naturally if you're getting omega-3 from fish. And so free fatty acids are actually very harsh on the gut. I remember this is something that I was looking at when I was a postdoc in Bruce Ames' lab, and my colleague at the time, Mark Shiganaga, was doing some of these experiments. He's a gut health expert, and he was basically looking at free fatty acids, and free fatty acids can actually be very hard on the gut, almost like a detergent. So I'm not sure that Epinova's gone anywhere since then, but it's kind of researchers are looking into the impacts of actually taking free fatty acid form of omega-3, maybe being a little bit hard on the gut. So that trial was actually ended early because it wasn't really showing any positive results. But the take home here is that the Reduce It trial and the Vital study really gold standard showing, compared to placebo, that if you take omega-3 fatty acids, even at a lower dose, it is reducing the cardiovascular events that occur with age. And there's many reasons why omega-3 fatty acids are beneficial for cardiovascular health. At the top of the list would be inflammation. So, inflammation is a driver of heart disease. It's a driver of atherosclerosis. And omega-3 fatty acids are, in my view, the most potent naturally occurring dietary compound that has anti-inflammatory effects. And it has it through a variety of ways. So both EPA and DHA, they get metabolized, and their metabolites help resolve inflammation. So if we're looking at EPA, they make resolvins, the E series of resolvins. DHA makes the D series, but it also makes the protectins and the neuroprotectins. And these molecules, they're not blunt force stopping inflammation. Like, you need inflammation, right? There's a reason why our immune system is active. You want it to be active, but you want it to shut off when it's supposed to shut off. And that's what these omega-3s are really doing. They're keeping inflammation in check. The other way that omega-3 fatty acids are cardioprotective have to do with the cells and the fluidity of them. And I told you we talked about this. So both DHA and EPA get incorporated into our cell membranes. They're a very important part of our cell membranes. These are lipid bilayers that surround our cell. And they really change the way our cells are, moving. So what they do is they make them more flexible instead of really stiff. So trans fats make cell membranes really stiff, and omega-3 fatty acids do the exact opposite. And it's very important, like if you're talking about the endothelial cells that are lining your vascular system, your arteries, if you're talking about the cells that are surrounding your myocardium, your pericardium, surrounding your heart, you want all those cells to be flexible and not stiff. And in fact, the stiffening of our heart with age has to do with that pericardium and myocardium stiffness. And so omega-3 fatty acids are really doing the opposite of what the stiffening is. It's making them more fluid. And that's another mechanism by which omega-3 fatty acids are very protective for the heart. So cardioprotective. Okay, I want to shift gears and talk about some data that I'm super excited about. This data has been emerging now for, the past 8 or 9 years. And by emerging, what I mean is we've had continual studies coming out, which just one after the other validating, confirming what has been shown, which is that omega-3 fatty acids slow biological aging. And what I mean about that is, we all of us sitting in this room, we're born, we have our birthday, we have our age, right? So I'm 47 and a half. And that's my chronological age. That doesn't necessarily mean that if you look at the age of the cells in my organs, in my blood, in my liver, that they're going to look 47 years old, depending on a variety of both genetic but also lifestyle factors. Importantly, your cells in your body can actually be either, much younger or much older than your chronological age. And it really depends on how you're living your life. And so biological age, typically we measure this through epigenetic aging. And these epigenetic aging clocks were developed by Dr. Steve Horvath when he was at UCLA. And there's a variety of different clocks that are used. There's the DNA Grimm age, the DNA Pheno age, and those are two of the major ones. And then there's some other ones as well. So we're going to talk a little bit about these epigenetic clocks, and what these are essentially just looking at DNA methylation patterns. And these methylation patterns are exactly that. They're a pattern that change with age. And the changing of these patterns really seems to be a precursor to the phenotype of aging and to the outcomes of aging, right? So the phenotype being frail, having diseases, and then the outcomes, dying from cardiovascular disease, dying from cancer, right? So the epigenetic aging clocks are very sensitive to the molecular events that are causing aging. And that's why we can measure these clocks and make an estimation about what our biological age is. So one of the first studies here, this was in 2019, showed that omega-3 does slow biological aging. This was a prospective study looking at people that basically reported their omega-3 intake, and the DNA Grim age clock was used in this study. And the DNA Grim age clock is a very, very accurate clock that can predict when someone is going to die. It predicts like your time to death, basically. And what it was found is that people with a higher omega-3 intake slowed their age acceleration. So, you're accelerating, your aging is happening at a certain rate. If you're smoking, it's happening at an accelerated rate. If you're taking omega-3, it's slowing that rate of acceleration. So it's slowing age acceleration. Another study that actually was published pretty recently in 2024, this study also looked at omega-3 intake, both, dietary, supplemental intake, and found that omega-3 did slow biological aging, and it really mattered. The dose really mattered, and this was based on gender. So for women, it took about at least 1 gram of omega-3 to start to slow biological aging in women, whereas for men, it actually happened at a lower dose. It happened at around 461 milligrams a day. So it seems like men must have more inflammation going on, because they seemed to be able to have an effect even at a lower dose. But this is really interesting, because you see, like, once you hit that 1 gram mark, that dotted line, this is age acceleration. You see that it slows, right? You're slowing your age acceleration after that 1 gram mark for women, and then a little bit sooner than that for men. Yeah, another study showing that. But what I'm even more excited about is the randomized controlled trial, because that really is, it gets rid of the confounding factors, because at the end of the day, a correlation study is just that. You're correlating things, and you try to, take into account all the potential other confounding factors. But when you have a randomized controlled trial, then you can really definitively say this is actually slowing aging. And so what this trial did was this was in Switzerland. And these people were very healthy to start. So I'll say this. Epigenetic aging wasn't found to be slowed by vitamin D alone, which other studies starting with vitamin D deficient populations have found that vitamin D supplementation does slow it. In this study, they only took 2,000 IUs a day. If you're deficient, it takes about 4,000 IUs a day to bring you up to a sufficient status. So in this study, they didn't see any effect on slowing of biological aging in, the vitamin D group. Exercise alone, so this exercise was resistance training. It was 30 minutes of resistance training 3 days a week. Keep in mind that 90% of the participants in Switzerland at the start of this study were already physically active, which is outrageous. So these are clearly physically active people. These are healthy adults, okay? You'd never find that in the United States. But they were already physically active, so there really wasn't much slowing of epigenetic aging after they're already being physically active, adding, the resistance training on top of that. But adding the omega-3 alone did slow epigenetic aging in this population. So this was the only thing that really had a profound effect. But what was really fascinating is that there was synergy. So when you looked at omega-3 plus vitamin D, it slowed epigenetic aging even further than just omega-3 alone. It slowed it by about 3.3 months. When you looked at all three combined, resistance training, omega-3, and vitamin D, it slowed it by about 3.8 months. So really, it was like these healthy lifestyle factors converging, with omega-3 being the thing that's really moving the lever. And you might look at me and go, well, Rhonda, 3.8 months, what does that mean? Like doesn't matter. I'm not talking about extending your life expectancy by 3.8 months. I'm talking about slowing aging. So we're talking about a cumulative effect, right? This is going to keep compounding year after year. And what I love about this study is they looked at that. So the 3.8 months of epigenetic aging slowing, that was the combined omega-3, vitamin D, and strength training. That also reduced pre-frailty by 40%. So even though it was only about a 4-month slowing of epigenetic aging, it reduced frailty by 40%, and it reduced invasive cancer by 61%. Wow, exactly. I mean, this is pretty exceptional. The omega-3 alone, without any other, vitamin D or resistance training, reduced infections by 13%, and it decreased falls by 13%. So the point I want to make here is that I know Steve Horvath, who developed these epigenetic aging clocks, over a decade ago. He's a friend of mine. I've talked to him the other day about this. I was so excited about this data. He says that these epigenetic aging clocks are very sensitive to inflammation. In fact, it's one of the things that really accelerates the aging process, inflammation. And we know that omega-3 is, as I mentioned, it has very powerful anti-inflammatory effects. I talked about resolving inflammation. EPA also can sort of directly affect inflammation through the leukotrienes and the prostaglandins. It can reduce a little bit of those as well. So the fact that omega-3 is really having a profound effect on biological aging, in my mind, is very important. We know we have the omega-3 index data, and we know the outcomes are also affected. We know cardiovascular death, is lower. We know that you're increasing life expectancy. And here we have, in real time, it's actually slowing the aging process. So this trial, by the way, was a 2-year trial. So I think that it's really important to keep in mind that you can have an outsized effect by something as little as, in this study, taking, let's see, what was the dose? In this study, the dose was 1 gram. It was 1 gram. Little as 1 gram a day had an effect on slowing aging. I mean, that's pretty profound. And so, as I mentioned, these epigenetic clocks are very sensitive to inflammation, and inflammation is at the core of aging. I mean, this is known. It is really, really one of the, I would say, molecular processes that is driving all these hallmarks of aging. It is driving, damage to your DNA that leads to cancer. It's driving damage to proteins that's leading to them aggregating and not being degraded. And you're getting these aggregates in your brain leading to Alzheimer's disease, and in your cardiovascular system leading to cardiovascular disease, atherosclerosis. It is fundamentally driving cancer. I mean, inflammation is at the heart of cancer. It's really at the core of every age-related disease. And we now know it's literally just accelerating the way our DNA is changing with time, right? This is the epigenetic clock data. It's really just at the fundamental level, changing our DNA and accelerating that. And so, I remember there was a study that was published, about 10 years ago. This was out of Japan. And in Japan, they have a high percentage of these centenarians, people that live to be 100, and the super centenarians, this is people that live to be 105, and also the super centenarians, that would be 110. And this Japanese study looked at, all these biomarkers to see, if I look at older adults, if I look at the centenarians and the and the super centenarians, like what sort of patterns arise? What can I tell from these biomarkers that's going to predict whether or not they're going to live to be, the next stage? And the only thing that was able to predict whether or not someone was going to go from being an older adult to someone that lives to be 100, and someone that lives to be 100 to 105, and so on, was suppressing inflammation. Nothing else predicted it, not low blood glucose, not lipids, not kidney function, liver function. Nothing else predicted it except for the ability to suppress inflammation. And not only did that predict the ability to live to the next, 105 or 110 being really old, but it also predicted cognitive function. So people were more cognitively aware, and they didn't have neurodegenerative disease as well if they were able to have low inflammation. And again, omega-3 fatty acids are doing just that. They're suppressing inflammation. They're resolving inflammation. They're doing it through a variety of mechanisms. They have these specialized pro-resolving mediators that are really keeping the immune response in check. And that is important because our immune system is getting activated every day. We're being exposed to all kinds of things, in addition to pathogens when you want it to be activated. I mean, just air pollution that we're breathing in constantly right now. Just normal, diet. You try to eat as healthy as you can. inflammation is being generated in the gut. It's constantly being generated. And so you really want to have something that keeps that in check. It also plays a role in increasing the cellular cleanup inside of ourselves, autophagy. And that is also very important for aging, as well as helping reprogram cells. But we're not going to get into all that today. Okay, I want to shift gears and talk about another really important area with omega-3 fatty acids and how it basically affects our brain aging, cognition, and the way our brain is aging. Omega-3 plays a very important role in the brain throughout the lifespan, from, we're talking in utero developments, when you're inside of your mom's belly and you're developing. From that point, even preconception. I mean, it plays an important role at every life stage. Right now, we're going to talk about more of the N type. We're going to talk about neurodegenerative disease, but I just want you to keep in mind that every stage is very important for brain health. So Bill and his colleagues have also published some studies looking at the Framingham cohort, looking at omega-3 index and Alzheimer's disease. And so again, what Bill found is that individuals that had a high omega-3 index had about a 50% reduced risk of Alzheimer's disease compared to people with a low omega-3 index. So again, this is correlative data. We're going to talk about strengthening that with some intervention in randomized controlled trials as well. But I mean, 50% reduction is really, really a big deal when it comes to Alzheimer's disease. Well, other studies have actually looked at omega-3 fatty acid levels and reducing Alzheimer's disease risk and found a dose-dependent decrease. And this always strengthens data when you can find something that is dose-dependent. So for every increase in, 100 milligram per day increase in omega-3 fatty acids, that was associated with lowering the risk of Alzheimer's disease and cognitive decline by 10%. So as it kept going up 100 milligrams more, you had a 10% lower risk of Alzheimer's disease. And you went up 10%, 100 milligrams more of omega-3 fatty acid, again, an additional 10% decrease in Alzheimer's disease risk. Again, so that's probably why when you get up to that high omega-3 index, which we'll talk about, it takes about 2 grams a day to get to that high omega-3 index. If you have a low omega-3 index, you could see where that 50% reduction comes into play because you keep going up in a dose-dependent manner. And this is an analysis of multiple different studies here showing that omega-3 reduces Alzheimer's disease risk in a dose-dependent manner. We also know that higher omega-3 index is associated with a larger hippocampal brain volume. So as we reach older adulthood, and I mean the age of about 65, we start to lose 1 to 2% of our hippocampus per year. So our brain is atrophying, and specifically our hippocampus is atrophying. And our hippocampus is very important for a lot of different brain functions, learning and memory being 2 of the most important. And so you don't want to lose 1 to 2% of your hippocampal brain mass per year, because that's going to affect your memory. It's going to affect your cognition, your executive function. It's going to affect everything, right? So there are studies that have found that a higher omega-3 index is associated with larger hippocampal brain volume. And that was also something that was found to be dose dependent as well. And so it was it's basically staving off that losing of the hippocampal volume. So you're going against what happens naturally with age, because inflammation plays a role in hippocampal atrophy. And so if you can negate some of that inflammation, you're going to keep some of your brain mass. And of course, that's probably partly why you see a lower risk of Alzheimer's disease as well. And there's also been some studies looking at omega-3 fatty acid supplementation in individuals with mild cognitive decline and how that can help improve cognition after taking omega-3 fatty acids versus placebo. So there have been a few studies. This is a meta-analysis of multiple studies as well. This is one study it was a 2-year trial. These patients had mild cognitive impairment, and they took 2 grams a day of omega-3 for 2 years. And after the 2 years, they had improvements in cognitive function, executive function, and importantly, they actually had lower plasma biomarkers of Alzheimer's disease. So they had lower amyloid beta in their plasma, but they also had increased markers of neuronal autophagy. So what that means, so neurons are you're not constantly making new neurons. They're called post-mitotic. So basically what you have is, pretty much what you're going to get. And so our brain has ways to get rid of, bad stuff that is accumulated in them. And that is through a process called autophagy. And so autophagy is very active in the brain because it's very important to keep our neurons healthy. And so there's biomarkers in the blood that are showing that that's going up in people that's supplemented with omega-3 compared to the placebo. So I think that this is also just strengthening the whole picture here that I'm trying to present to you, which is that omega-3 fatty acids are very important for brain health. They're very important for preventing inflammation in the brain, which does lead to brain atrophy and also lead to neurodegenerative diseases like Alzheimer's disease, dementia. And so it's something to keep in mind. As I mentioned, 90% of the US population does not get enough omega-3 from their diet. So there's a variety of reasons why omega-3 is improving brain health, inflammation being at the core. We talked about that. But also the cell membranes. It's in our neurons, the cell membranes are very important. And the fluidity, much like in our cardiovascular system, the fluidity is extremely important because all of our transporters and receptors for neurotransmitters, they're all in that cell membrane. It's very important for the structure and function of our receptors and transporters. And so it's globally affecting neurotransmission. When you have a cell membrane that's not getting omega-3 and in the brain, what happens is, and there's studies that have shown, if, for example, you take animals like mice and you make them omega-3 deficient, their glucose transporters aren't functioning right because they're structurally, like the membrane's too stiff. And so the transporter, it's not right. And so glucose can't get into the brain. And so this, over time, it's going to affect your cognition in the short term. You're going to feel brain foggy. You're not going to feel sharp. But over time, what's going to happen is low glucose in the brain affects a lot of different processes, right? Neurotransmission, it also leads to the accumulation of tau tangles. This is a hallmark of Alzheimer's disease as well. And so it's really essential for their cell membranes as well as boosting neurotransmission. So there have been studies also showing that EPA and DHA are important for dopamine, serotonin. When you have high inflammation, it stops the release of serotonin. You're not able to release serotonin from the presynapse. And so it's really just globally affecting neurotransmission, neuroplasticity. It's affecting the transporters and it's affecting inflammation. So there's a lot of ways that omega-3 is really behind the scenes improving the way your brain is aging. And when you don't have omega-3 there, not only is it not countering the inflammation, but it's affecting just global nutrient transport into your brain and global neurotransmission. Okay, we're going to shift gears now again and talk about omega-3 briefly in the muscle. And this is something that not a lot of people are aware of. And I think it's an important topic. So, some of these studies that we're going to talk about come from Stu Phillip and Chris McGlory when he was a postdoc in Stu Phillip's lab at McMaster University. Chris McGlory now has gone on. He has his own lab and he's continuing to research this topic. But let's take a step back for a moment and just talk about muscle mass and, during the aging process, because it's important to understand this, to understand how omega-3 is impacting it. So muscle mass is very important for how we're aging. Obviously, frailty, if you have a fall, the more muscle mass you have, the less likely you are going to fall. And if you do fall, you're going to bounce back quicker, right? So as, throughout our life, we reach our peak muscle mass at around the age 20 to 30. Then we start to lose, on average, about 8% per decade after that. Now, this is, when I say on average, I mean the average person that's probably not really physically active. If you add in resistance training to that mix, you're probably not losing 8% per decade. The average person then, when they hit the age of 70, starts to lose 15% per decade. And as people get older, they become less physically active, right? As someone reaches the age of 70 to 80 years old, they have about 60 to 80% of the muscle mass they had when they were 30. It's really, really a profound decrease. And so you really want to try to increase your muscle mass as much as you can, before you get to that point. And it's important to realize that as we age, so what's important for increasing muscle mass? Amino acids and resistance training, right? The training is the mechanical force helps you increase muscle mass. So those are the two most important signals for increasing muscle mass. as we age, we become less responsive to amino acids. So it doesn't have the same anabolic effect that it does when you're younger. Amino acids are much more anabolic in a 30-year-old than they are in a 70-year-old, unless they're training. Physical activity, and particularly resistance training, resensitizes the muscles to amino acids so that it's almost like you're younger again. And that's really, really important because most people are not training. And so this is called anabolic resistance. You're basically, when you get older and you're not physically active, your body is not responding to amino acids. Your muscle's not responding to amino acids the same. And so you're not building muscle the same way you did when you were 30, for example. Why is this important? This is important because disuse atrophy events happen. They happen because they're planned. So surgeries, when you're undergoing any kind of surgery, you're going to have a period of time when you are not mobile. You are not using your muscles. And when you're not using your muscles, you lose them. You lose them. They atrophy. This could happen because you fell. You had a fall. So you're not going to be mobile for a period of time while you're recovering. This could happen because you have the flu or some other respiratory disease and you're not moving around, right? So there's a lot of reasons why particularly older adults have disuse atrophy events, planned or not planned. And when they lose that muscle, it is catastrophic because they can never gain it back like they had before they lost it. And it's very, very hard for them. And anyone here that has grandparents, parents that are aging, that have had these disuse events, you'll see they start to compound. They have one and then another. And the next thing you know, they can barely walk to their car. I mean, they lose it quickly. It's a very accelerated downhill trajectory. So disuse atrophy is a problem. And anything that you can do to slow disuse atrophy is hugely important, hugely important. And this is where Chris and Stu Phillips came in. So they were looking at omega-3 fatty acids and their effect on disuse atrophy. And you can't do this experiment in older adults. It would be unethical because they do lose a lot of muscle mass and it's really hard to gain it back. So they did this study in younger women and they gave these women for 4 weeks ahead of time, they gave them 5 grams of omega-3. It's a high dose of omega-3. Remember, prescription forms of omega-3 are about 4 grams a day. So they were going above that, but they were doing it for a month. And the reason they did the high dose is because, as in any experiment, whether we're talking about creatine or omega-3, there's a loading phase where in this case, both the researchers, Stu and Chris McGlory, were trying to get omega-3 fatty acids to accumulate in the cell membranes in the muscle, because it takes about 1 month for that to happen. So that's why they preloaded them for 1 month with 5 grams of omega-3, and then they immobilized their legs. So you put like a cast, around the leg so that they're basically not using one leg. And you're looking at muscle mass loss over that period of time. And what was found was that the women that were given this omega-3 fatty acid supplement, it cut their disuse atrophy in half. So they lost only 50% of what they would have lost if they didn't have the omega-3. I mean, it's a huge effect. And I think this is really, really important because, again, if you can give older adults an omega-3 supplement and make it where they cut their disuse atrophy in half, it is going to have a profound effect on these events, because that really does eventually affect their trajectory and into their mortality risk, right? So some follow-up studies by Chris McGlory have found that actually it doesn't really even seem to be the inflammation that's playing a role in this disuse atrophy. It's the accumulation of the omega-3 in the muscle cell membranes. And we've been talking about transporters, right? Well, amino acids are transported through a transporter. And what it seems to be going on is that the omega-3 in the cell membrane is sensitizing the amino acids in the muscle tissue like they were young, like what exercise does, right? So very interesting new data coming out of Chris McGlory's lab. I would say then, in the case of someone who's supplementing with omega-3, then maybe you would imagine that they would have more muscle mass, like an older adult. And that's exactly what's been shown. So there's meta-analyses of studies that have found that if older adults supplement with 2 grams of omega-3 per day, they actually have higher muscle mass, they have improved walking speed. And I think this is very important because and it's not even necessarily in the context of exercising. They just have increased muscle mass. likely because all their sedentarism, the disuse events, they're not losing as much muscle mass from them because they have that omega-3. So pretty powerful data. And then we're going to move on to the last part of the talk here. I've got 6 minutes left. That's perfect. We're going to talk about the role omega-3 plays in what is kind of known as leaky gut, or what I like to call gut permeability. And this is also very interesting data because we've been talking a lot about the role of omega-3 in inflammation. It seems as though there's multiple layers to this. So our gut is the home of like trillions of bacteria, right? We've got like trillions of bacteria in our gut, many of them at the distal end of our gut in the colon. Some of these bacteria are good, the probiotic kind, and some are bad, pathogenic kind. But regardless, bacteria in our gut, particularly the gram-negative bacteria, have a component to their outer membrane. The bacteria have a component called lipopolysaccharide. It's also referred to endotoxin. They're kind of the same thing, lipopolysaccharide. We have about 1 gram of this lipopolysaccharide in our guts at any given moment. It's a lot of it just sitting around. And that's because bacteria are often dying in our gut, right? And so when they die, you still have those dead cells there. And when we eat a meal, even if it's a healthy meal, we have a transient opening of the epithelial, cells and the junctions that are connecting our epithelial cells lining our gut. There's a transient opening of it, and then it closes. But when you have that opening, guess what comes out? LPS. LPS comes out, and this is kind of part of what's called the postprandial inflammatory response. You may have heard of the postprandial glycemic response, right? Or glucose response, where your blood glucose levels go up after a meal because you're eating carbohydrates. Well, guess what else goes up? Inflammation goes up after a meal because LPS is being released into your bloodstream after a meal. Now, the degree of how much LPS is released depends on the meal that you're eating. It also depends on whether or not you have celiac, for example. People with celiac, if they have any exposure to any sort of gluten, those junctions are open and the floodgates are out, and inflammation and LPS is going into their bloodstream. If you eat a high fat, high refined sugar, ultra processed foods, the standard here, that's really going to cause a lot of leaky gut. It's going to make, your intestines are going to become permeable, and LPS gets released into the bloodstream. I'm going somewhere with this. So the LPS, this is, in your body, it's in your circulation now where all your immune cells are, okay? And it sees LPS and it thinks this is bacteria because it's part of a bacterial cell membrane. So it's ready, it's primed to fire away, to fight the invader, right? It's not really an invader, it's just something that was released because, we ate a meal. Part of the adaptive response here is that we start to increase our lipoprotein production. We make more VLDL and LDL, and that binds to LPS and sequesters it and prevents it from, actually causing a lot of harm. So that's one of the reasons why you never want to go get your LDL measured right after you've been sick or if you've had some kind of really stressful event, because stress causes inflammation, and inflammation will make your LDL number go up. Just FYI, always do an N of 2. But that's a little side note here. So the binding of LPS to these LDL particles, what's happening now is it's binding to a certain region. It's binding to the region called ApoB. And the ApoB part of the LDL particle is very important because that is the part of the LDL particle that gets recycled back to the liver so that your LDL levels aren't staying around forever in your bloodstream. But LPS is obscuring that ApoB, and so it does not get recycled, and so it stays around in circulation longer. And what happens is, as it stays around, it's delivering triglycerides. What lipoproteins are doing is they're delivering triglycerides and cholesterol, mostly triglycerides, fatty acids, to your other cells. And for repair, you need them for repair and things. But now this LDL particle can't go back to the liver. It's got to stick around longer. It's smaller in size. It becomes what's called a small, dense LDL particle. And what happens is that small LDL particle lodges itself in your arterial wall. And because the LPS is a signal for the immune system, hey, bacterial invader here, the first line of defense is macrophages. It's a type of immune cell that come and engulf bacteria. They eat bacteria up so that it doesn't kill you. Well, they come thinking it's bacteria, but really it's a small, dense LDL particle lodged in your artery. You got this macrophage that tries to eat it, only it can't because it's stuck to an LDL particle. And so now you have the beginnings of what's called a foam cell. It's like a macrophage there, and it's, making cytokines and stuff and now bringing more. And so you have the start of atherosclerosis, all coming from gut permeability, all coming from LPS leaking out into circulation. Why am I getting to this point? Well, the other thing is also that this LPS is affecting the brain. And, so I'm talking about cardiovascular health. I'm talking about now that the LPS is increasing, inflammation, and that inflammation is affecting the brain. And I will just say this, that there have been studies that have injected LPS at a normal level that you would find being released in the circulation after a meal after a bad meal, we'll say. They've injected it into healthy patients, either LPS or a saline control, and injecting the LPS into those individuals increases their inflammatory biomarkers, but it also increases depressive symptoms. It increases, social withdrawal as well. Within that same study, if individuals were given an omega-3 supplement before they were injected with LPS, their inflammatory markers weren't going up as much and they weren't getting the depressive symptoms. But that's a whole other story in terms of studies have shown that actually inflammation is a major part of depression, and omega-3, particularly EPA, seems to be very powerful at reducing depressive symptoms in people with major depressive disorders. I'm unfortunately not going to get into that today. It was kind of a side note here because it's all back to the LPS, right? LPS is affecting cardiovascular health. LPS being generated from the gut is affecting your brain. This is why you hear a lot of people talking about gut health. Gut health is at the core of our health in general, and it really is true. Why am I telling you this? Because omega-3 actually decreases LPS release after a meal. So in this study here, there is a low fat and a high fat meal. Typically higher fat meals do increase more LPS because fat can kind of lyse the gut cells and be an irritant on the gut. But omega-3 in the green at every point, at the baseline, it seems as though the omega-3 group actually had a higher LPS. But after the meal, you can see it's suppressing the release of LPS and endotoxin into your bloodstream. And which is kind of why I like to spread my omega-3 intake out throughout the day. But it's very powerful and important here because now we're talking about not only is omega-3 fatty acids reducing inflammation at the level we already discussed with these specialized pro-resolving mediators and the protectins and the resolvins, but even at the level of the gut. And we know that from animal studies looking at mechanism, that omega-3 fatty acids in the gut, when you take the omega-3 fatty acids, they're working on site. They're working at the first, organ that sees it, which is your gut. And it's increasing the level of a protein called IAP that degrades LPS in the gut. It degrades LPS in the gut, and it also kills the bacteria that are producing LPS. And so what I'm getting at here is there's so much to omega-3 when it comes to inflammation. We're just scratching the surface of understanding how it is so powerful at reducing inflammation, everything from cardiovascular health to inflammation in the brain to muscle to the gut, the originator of a lot of inflammation in our body. So I'm going to end with that because I think it's very important. And in conclusion, what can you do? What are the take-homes here? In my opinion, one, everyone needs to measure their omega-3 fatty acid levels. You don't know what you don't measure. And so you want to get this omega-3 index test, which I heard may be in a little baggie floating around today, which is kind of cool. The omega-3 index test, you want to be at that 8% range. How do you get to that 8% range? Well, a lot of people can try to consume, fatty fish that are high in omega-3 fatty acids, low in contaminants like mercury. Salmon, wild Alaskan salmon is my favorite. Not everyone likes to eat salmon and certainly doesn't want to eat 3 to 4, I don't know how many servings a week it will take. You have to measure your omega-3 index to see. Not everyone likes to eat that fish because one, unfortunately, our fish are contaminated with microplastics and they're contaminated with mercury and PCBs and all kinds of environmental toxins. And some people just don't like the taste. So Bill Harris has done some studies also looking at what it takes to get someone from a low omega-3 index of 4% to a high omega-3 index. If they supplement, it seems as though if they're taking a triglyceride form, a little bit, maybe 1.5 to 2 grams a day. I like to say 2 grams a day is really to be safe, but 2 grams a day of omega-3 fatty acids seem to get people from a low to a high omega-3, index level. And that's really where you want to be. And that's where you want to be for the brain benefits. That's where you want to be for the cardiovascular benefits, for the reducing, aging. It seems like it's a pretty good sweet spot. And that's what I take. So with that said, thank you so much for listening. I hope you learned something today. And I think I have some time for questions.
Thank you so much, Dr. Rhonda Patrick. We're going to do Q&A. We do have the room until 12:15, so we do have a little time here. If you do need to leave and you're hopping over to another session, make sure to get your gift bag in the back with your complimentary omega-3 index test kit. Since I'm right here, I'm going to go with you first.
Thank you so much. Great talk. I see that you recommended 2 grams a day. What is the ratio that you generally recommend of the DHA and EPA?
Yeah, that's a great question. What is the ratio of EPA to DHA? And I think that really depends on what outcomes that you're looking for. I think that, if you're looking, the data really shows for cardiovascular health, EPA is very important. DHA is as well. It's the cell membrane component. Mostly DHA is getting into cell membranes, EPA too, but to a lesser extent. If you're looking for a lot of the brain benefits, Alzheimer's disease, DHA really shines there again, probably because that cell membrane component. Same with the muscular effects. So personally, I like to go for closer to a 2-to-1 ratio. I actually like DHA. I like a little bit higher DHA for me. For me, yeah. But, other people might want to go the opposite direction. Right. Yeah.
Perfect. I'm going to continue in this row, and I'm going to hop over here.
We know there's been great studies on the efficacy of supplements. Have you seen any or done any work on consuming through whole fish consumption versus supplementation? What are your thoughts on that in terms of efficacy and effectiveness?
Yeah, so several of the studies that I presented, even some of the initial omega-3 slowing biological aging, the omega-3 index, studies looking at 90% reduced, sudden cardiac death. Those were really omega-3 intake, and it was people that were eating fish and or supplementing. So it's really kind of a combination. And so there's definitely if you can get your omega-3 index up to that level from diet, it seems to be protective as well.
Perfect.
Is that your question?
Yes. So
Comparing one to the other, not directly.
You good? Okay, perfect. I'm going to hop over to you.
So how many gel capsules would that be for 2 grams?
It depends on how concentrated the supplement you're taking is. For me, it's 4. But I like to find a more concentrated. It's hard to get 1 gram of omega-3 into just 1 capsule. So generally, I would say 2 grams in general would probably be about 4 capsules.
My name is Ati Hakimi. I'm a family medicine physician. It's the first time I've attended this conferences. That was outstanding, you guys. That was absolutely outstanding. And cardiovascular disease is our #1 killer for every single person in this room. Please listen to everything she said. That was absolutely outstanding. So my question is, we are working in a sick care system in our country. We wait for people to get sick. We work backwards. That's not my goal. So how soon can I start doing this for my people? Because I have kiddos, right, that already have hypertension, diabetes. Yeah, we live in a sick care model, and I'd rather practice healthcare. How soon can I start doing it? Can I start reversing things for people that already have it?
I personally think that omega-3s are important, starting, like I said, from, you're in the womb, in utero, developing. I give my son is 8 years old, and right now he's getting about 1 gram of omega-3 a day. So, I do recommend that, some kids like to eat fish, mine doesn't. So omega-3 supplementations is only real omega-3 fatty acid source. But I think it's important starting as soon as you can. And the data really supports it. Also, data supports it for cognitive health in children as well. And there are studies showing that 1 gram a day is safe in children, and it lowers ADHD, it improves cognition. There's all sorts of, in addition to cardiovascular benefits, just brain benefits for children. Autoimmune, we could have talked for hours about every possible disease. It's pretty ubiquitous.
I'm a biochemist myself, but Is there like an upper tolerable limit? Are there people getting too much? Because I know DHA has a bunch of double bonds and it's easily oxidized, prone to lipid peroxidation. And if you have too much in your membrane, it can be deleterious. Did they do any studies showing like, oh, this person has way too much omega-3, he's probably going to get sick or anything like that?
There's been studies like Bill did studies, gosh, back in a long time ago, maybe in the 1980s, giving people 30 grams of omega-3 a day, and there was no negative effects. And I don't remember how long. I'm not saying that there aren't. I'm just saying that he had done, for the short amount of time that he did it, there was not. I think that, we know that prescription forms are 4 grams a day. And this is Visipa and Leveza. So, yeah, I think it all depends on the person, and there's always an upper limit. And so it's better to kind of stay within that safer range and talk about that with your physician. But oxidation, your cell membranes only take up so much. Like if you're over flooding the system with DHA, you start to metabolize it like through fatty acid oxidation. So that's what happens.
Perfect. One more over here, and then I'm going to jump to that side.
First off, I think I don't work for Nordic Naturals, but they do have a 2X that gives you 1 gram in a soft gel.
Oh, nice. And 1 capsule?
Yeah, and all liquids give you more than that.
Yes, the liquid.
Yep.
Yes.
So, but would you speak to the difference between ethyl ester and triglyceride? I know I've listened about 20 times to your conversation with Dr. Harris from 22. So Found My Fitness for people who want the long form. She does a great talk with Dr. Harris. But,
thank you.
And all kinds of citations, which you can read. But if you would speak, because on his Oméga Quant website, he has a calculation, how much triglyceride you'd have to take to get to that 2.2 grams and how much ethyl ester you would take.
Yeah. So the difference between, and I'm going to just give a very general overview here, the ethyl ester versus triglyceride. So when omega-3 fatty acids are isolated from fish and they're purified, they're oftentimes run on a column to purify away things like PCBs and mercury. And so the triglyceride backbone is removed and they're basically run through this alcohol column. And so it has basically an ethyl ester backbone to run it through the column to purify it. And I think a lot of supplement companies will leave it in that purified form, ethyl ester form. That's not a naturally occurring form. So when we metabolize, when we're taking an ethyl ester form, it's very different in terms of like the enzymes that are cleaving things and how much we absorb. So we absorb far less of omega-3 in ethyl ester form than if someone were to then take that omega-3 that's been purified and then re-esterify it on a triglyceride backbone, which is I would say more of the gold standard in my opinion, because you're absorbing so much more of that omega-3 from the triglyceride form. So Dr. Harris on his site does have a calculation that's done, and I think that the calculation shows that if you're taking triglyceride form, you may not need 2 grams, you may need like 1.7 or something like that grams versus the 2 if you're taking ethyl ester form. At the end of the day, I don't think you should just go off the calculation. You should take the omega-3 index test, before and maybe like, a few months after you're supplementing, right? So 120 days at least wait before you take the test again. I would wait a little bit longer and see if that dose is right for you, because I've seen people that have taken 2-3 grams of ethyl ester form and still not raise their omega-3 index. So really testing is an important part of this equation here.
Amazing. You had a question here, right? Perfect. And then I'm seeing we're back.
Dr. Patrick, thank you. Excellent presentation. What do you make of the three recent FARI papers that all showed better avoided risk from things like early onset dementia, anxiety, depression, lifetime history with the non-DHA component and the other omega-3 in plasma?
You're talking about EPA?
Well, the studies found that the sum of ALA, EPA, and DPA had better avoided risk for those eventualities than the DHA component, which ties most heavily to the omega-3 index.
I haven't seen that study, but I mean, I've seen a lot of other studies showing that DHA and EPA are very, very important. I mean, in terms of their metabolites, as well. So I'll have to look that study up.
I had a couple questions up here. Yes, you've been waiting. Thank you.
Thank you so much. I have a question. I really love eating seafood, but considering all the impurities in the seafood these days, like the microplastics, heavy metals, antibiotics, do you think it's still worth eating seafood for omega-3s, or should we just take the supplements? And are those supplements tested for heavy metals and microplastics? And question number 2, would you have time to come on my podcast in Australia to talk about this more in detail? It's online.
So the question is like, do I think it's safe to eat seafood? I eat salmon like 2 or 3 times a week, very small 4-ounce piece, wild Alaskan salmon. It does have the lowest amount of mercury contamination, but the microplastics are a concern. I will say this about microplastics. They do accumulate in the intestines. And so eating like shellfish or fish that have the full intact, or like a sardine, like the full sardine, that's the worst thing you can do, because if you're eating the intact digestive tract, that's where all the microplastics are accumulating. So, but there's still probably some in the muscle flesh of the salmon. I still think it's healthy. There's so many studies out there showing that salmon is correlated, eating salmon is correlated with so many health benefits. So at the end of the day, even with the contaminants, in fact, there was a study, you remember that, you're probably too young, but like for a long time, OBGYNs were recommending pregnant women to not eat fish because of the contaminants and the mercury and how it was going to have a negative effect on, brain development in utero. And so all these women stopped eating fish, and it was really terrible because that was like their only source of omega-3. And it turns out that newer studies have come out since then that show that even women eating a lot of fish, in fact, the omega-3 fatty acids were protecting against the mercury toxicity. And there was even one study that was published a few years ago that showed higher levels of mercury, which was indicative of higher omega-3 intake, because people that were taking in fish had higher mercury, actually was a biomarker for intelligence, and the children had higher intelligence quotient scores, so IQ scores, if they had higher mercury, not because mercury is improving brain function, but because they were getting omega-3 fatty acids. So in other words, obviously, and this is kind of why I want people to think about food in a way. I want them to think about food not so much about what you have to avoid, but what you need. And you need omega-3s, and they are so powerful. So I do a combination of both, because I'm not able to get my omega-3 index up to where it needs to be with just eating salmon.
Just a quick follow on, because she asked half of my question. Between farm raised and wild caught, besides the detriments of contamination, is that from a strictly omega-3 perspective, is there one that's preferred, or like get it in however you can?
Yeah. It's an interesting question because, it depends on like some of the farm raised salmon, they're not eating the right foods that normal salmon are eating in the wild. So a big part of that would be like the little tiny fish that have astaxanthin in it. Astaxanthin is a carotenoid that gives salmon its pink color, and it's also very beneficial as well. So in the farm-raised salmon, they're feeding them other, I hate to say, maybe even corn, stuff. Like, it's not really great. And so they have to inject the salmon with actual astaxanthin. And they do that, like farm-raised salmon, they're basically albino. So, there's a little bit of like, well, there might be a higher omega-6 ratio in those types of salmon. But the omega-3, as long as there's enough omega-3 there, it's probably fine. And I've changed my mind somewhat on this. I used to kind of been like, oh, only wild, like don't do the farm. And then some newer studies have come out showing that farm salmon raises omega-3 fatty acid levels, like just as good in some cases. So don't sweat it too much. Yeah, I definitely eat it when I'm out. I know at the restaurants it's probably farmed, right? So I eat wild at home. When I'm out at a restaurant, I'll do the farmed, and I'm not like dying over it, Yeah.
This is my 13th expo, and I have to tell you, this is my favorite talk I've ever done. So thank you.
That's amazing.
Can you speak to the omega-3 content of canned fish?
Sure. It depends on the kind of fish. I would say that there are sardines that are very high in omega-3. In fact, I mean, I used to eat sardines that had like 500 milligrams of DHA in them, which is pretty high. The only thing now is the microplastics. They have to be like the sliced sardines. I don't want to eat the whole digestive tract. And then there's the canned aspect. I think tin cans they're not lined with plastic, so there shouldn't be as many plastics leaching into them. But I do think they're, again, a good source. And I'm not as concerned about the mercury, because if a developing fetus, which is very, very sensitive to mercury, way more sensitive than we are as adults, if they're okay and protected by the omega-3 fatty acids, I feel a lot better about eating some sardines and getting some mercury in there.
Hey, right here. Thank you so much for being here. Thanks for Found My Fitness, your recipes, all the tools that you have on your websites and everything. I'm actually a fish farmer, an aquaponic farmer, so raising fish to produce plants. Thanks. So yeah, in an environment that's recirculating with no heavy metals, no microplastics, things like that, and where we can actually tailor the diets, add supplements to the diets, things like that. I was curious but you kind of answered it, if you have an opinion on that. But on from that, do you see market shifts or potential products coming from microbial sources, whether it's bacteria being able to generate these things, or if you have
I'm excited about all that research that we can. Some people are really scared of genetic engineering. I'm not one of those people. I mean, it depends on the context,
Sure.
Right? But when it comes to generating omega-3 in a more sustainable way, I'm very excited about that possibility. I think we will eventually head there, actually quite soon.
Yeah.
But I have a question for you.
Sure.
Have you seen any studies that have compared microplastic levels in farmed raised fish versus wild fish, or has that been done yet?
Studies, not necessarily. I'm part of the Aquaponics Association. We're a multinational aquaponics focused association. I've got colleagues at universities and small farms, large farms. It's something that we talk about, but the way that we design our systems is with generally PVC pipes, and then I'm trying to remember the acronym for the plastics used for the tanks, but it's all food safe plastics. So generally we like to think that our microplastics are a lot lower. The only inputs are filtered water, the feed, and the supplements, calcium carbonates and things like that. So
I'm going to look that up when I'm done.
Yeah.
Thank you so much. All right. We actually have to quickly leave this room. We have one last one I'll ask on your behalf. When's the best time to take your omega-3 supplements as our grand finale?
I think the best time to take them is when you're going to consistently form a habit to take them. And don't worry about it really is the day, because there's studies showing that if you take an omega-3 fatty acid, these SPM molecules, they're resolving inflammation, stay in circulation for 24 hours. So you're good. You're covered the day.
So much. Dr. Rhonda Patrick.